My dear students, a very pleasant morning to you all. Redox reactions welcomes you back once again in NEET session. Today we will solve some set of 20 questions which have been appeared in the NEET examination, previous year NEET examination. So before you solve the MCQs, PDF of these MCQs will be given. It will be put up in the group. You either write down in your notes or take the printout copy of it. So today we will solve some of important MCQs of redox reactions. Right? Yes. Today we will solve the redox reaction. Redox reaction. So, as NEET is concerned, minimum you will get one question in the NEET, and applications of redox reactions you will get in the block elements, especially in the P block element. You will get some MCQs based on redox reactions. Now, first of all, let's see the first question, how the first question appears. So look at the first question. Now the first question, it is given like this. One of the question appeared in the NEET aims. Addition of oxygen to an element or a compound is termed as. ಅಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಆಡ್ ಮಾಡಿದ್ರೆ ಎಲಿಮೆಂಟ್ಗೆ ಅಂತ ಕಾಂಪೌಂಡ್ ಅಂತ ಒಂದು ಕಾಂಪೌಂಡ್ ಏನಂತ ಕರಿತೀವಿ ಅಥವಾ ಆ ರಿಯಾಕ್ಷನ್ಗೆ ಏನಂತ ಕರಿತೀವಿ. ಸೊ ಸ್ಟ್ರೈಟ್ ಫಾರ್ವರ್ಡ್ ಕ್ವಶನ್. ಆಪ್ಷನ್ಸ್ ಆರ್ ಗಿವನ್ ಫಾರ್ ಆಕ್ಸಿಡೇಷನ್, ರಿಡಕ್ಷನ್, ಅಯನೈಸೇಷನ್, redox reaction. Yes, I think the answer is coming on your lips. I'm sure. Addition of oxygen is simply oxidation reaction. So, for question number 1, the correct option is option A, oxidation reaction is the correct answer. Question number 2. Substances that are oxidized and reduced. Be careful, this is oxidized as well as reduced. First is oxidation, then is reduction. In the former reactions are respectively. This is the reaction. Let's write down the reaction. Reaction is given. Question number 2. The reaction, please write down the reaction. N2H plus one more is given. 2H2O, I think 2. This is called as hydrogen peroxide. Then comes N2 plus H2O. What exactly is asking that we have to see? What is exactly asking? Asking is, first is oxidized and reduced. First is oxidized and reduced. Which one will get oxidized and which one will get reduced? Let's have a look. Now first find out the nitrogen charge. It is a free state. Straight away I can write its charge is 0. Find out the charge of nitrogen here. When you calculate the charge of nitrogen, somewhere you calculate N to H. I think yes, N to H. And sorry, N2H4 it is. N2H4. I'm sorry, I forgot to write 4 here. 4. So N2H4. In N2H4, which one is more electronegative? This one. Then hydrogen must be electropositive. Then 2x plus 4 equals 0. X is equal to, I think, minus 2 you will get. Minus 4 by 2, minus 2. Then charges you write in minus 2. Then from here to here, it get reduced. It get reduced. It get oxidized. Sorry, the charge is minus 2 to 0. Minus 2 in the 0. Charge increase. Charge increase, so it is oxidized. This got oxidized. Then what is the charge of oxygen here? Don't see, charge of hydrogen is +1. Here also +1. There is no change. See, charge of oxygen in hydrogen peroxide. Charge of oxygen in hydrogen peroxide is always -1. Charge is always -1. Even if you calculate, it will get -1. So charge of this oxygen is -1. Charge of oxygen in water is -2. You calculate, you will get. So -2, -1 to -2. -1 in the -2. Charge in a decrease aitala. Charge decrease. So charge decrease. So it is reduction. So which one get oxidized? Which one will get reduced? This one get oxidized and this one will get reduced. So the answer is oxidized and reduced. N2H4 get oxidized, H2O2 get reduced. So yes, such the option. So N2H4, yes, N2H4 is given, H2O2 is also given. The correct answer is option B. So correct is option B is the correct option. Option A is correct option. Next question. Question number 3. What is question number 3 given here? Here it is. Very potential question, very important question in the redox reaction series. So let me explain you about this. Oxidation state of potassium in KO2. KO2. Let's write down question number 3. KO2. Now you need to understand little more about the oxides. Generally, there are 3 types of oxides. For example, the same thing, KO2, K2O, or K2O2, K2O. Very important. Very important. What is KO2? What is K2O2? What is K2O? You need to understand. When you separate the charges, when you calculate the charge of potassium is always +1. Since it is first group element. Always +1. Don't get confused. Even in the last year, KDPY also same question was appeared. So please concentrate carefully. Okay. This is also potassium oxide. This is also potassium. This is also potassium oxide. But what is the exact name of this? This is called. Now, if the charge of this potassium, KO2, if charge of potassium is +1, then what would be the charge of this? This should be -1. So oxygen charge is -1. If charge of this oxygen charge, here it is. minus 1. Now, how this minus 1 comes here? Let's find out. It is not minus 1, it is minus half something it will come. Let's find out. What is the charge of oxygen? So, charge of potassium is plus 1. Then charge of oxygen we don't know, let it be x. So we can calculate something like this. Charge is plus 2x is equal to 0. Then x is equal to minus 1 by 2 half. Minus 1 by 2. That is minus half. Here when you calculate charge of oxygen we don't know. So charge of potassium is always plus 1. Let's find out. 2 minus plus 2x is equal to 0. 2x is equal to minus 2. X is equal to minus 1. Then charge of potassium is always plus 1. Oxygen charge, let's find out. Oxygen charge. Okay. Charge of potassium is plus 1. So 2 plus x. Charge of oxygen we don't know. So x is equal to minus 2. This is the special case. Generally charge of oxygen is minus 2 only. But special cases generated in this type of cases, if the charge of this is minus half, then such types of things are called as superoxide. This is called as superoxide. This is called as peroxides. This is called as oxides. Don't get confused. If the charge of oxygen is minus half, then it is called as superoxide. If charge of oxygen is minus 1, then it is called as peroxide. If charge of oxygen is minus 2, then it is called as oxide. Come on, let's make this now. This is called as potassium superoxide. So it comes potassium superoxide, potassium peroxide. Simply add potassium oxide. So anyhow, this is not related to this type of question. Only thing is to know the charge of which one? Oxidation state of potassium. Straightforward question. Some students will get confused with this. If the charge of oxygen is minus half, then it should be like plus half. No, it is not like that. Charge of potassium is always plus 1. Option C is the correct option. Option C is the correct option. Let's move on to the next question in the second slide. Question number 4. In Br3O8 compound, oxidation number of bromines. You need to find out oxidation number of bromine in Br3O8. Let's write down. So question number 4. Br3O8. What to find? Its oxidation number. We need to find Br charge. We don't know, let it be x. Unknown. So 3x. Charge of oxygen is always minus 2. Number of oxygens are 8 is equal to 0. 3x is equal to plus 16. X is equal to plus 16 by 3. Which is option? Option is A. Option is A. So the next question. Sorry, not option A. Option D. Correct option is D. D. Correct option is D. It is given 13. So last option, it is 16 by 3. Very important type of question. For the reaction is here. This is the reaction. The correct stoichiometric coefficient of MnO4 minus C2O4 minus H plus R. First write the reaction. We need to balancing reaction. So question number 5. So given is MnO4 minus plus C2O4 plus 2 minus I think 2 minus then comes H plus gives you Mn2 plus CO2 plus H2O. Now you need to balance it. Before you balance, what you have to do? This coefficient is asking. This coefficient, this 3 coefficient is asking. That's it. Keep it in mind. It's very simple type of question. Now before you calculate, just find out the oxidation number of Mn. Same way you have to balance that. How you are going to balance in the class? So charge of Mn in MnO4 minus is +7. We know how to find out. Charge of carbon we need to find out. Charge of carbon right now presently we don't know. Let it be x. So 2x minus 4 oxygens. So 8 is equal to apparent charges minus 2. 2x is equal to plus 6. X is equal to plus 3. Then we got plus 3. Then charge is given. Charge of carbon in carbon dioxide is plus 4 if we calculate. Now after that you just draw which one will get oxidized and which one will get reduced. Now before that, which one will get oxidized? Let's see. Mn to Mn, we will draw lines like this. +7 ಇತ್ತು +2 ಇದೆ. ಹಾಗಾಗಿ ಇದೇನಾಯಿತು? ರಿಡಕ್ಷನ್ ಆಯಿತು. ಎಷ್ಟು ಯೂನಿಟ್ಸ್ ರಿಡಕ್ಷನ್? 5 ಯೂನಿಟ್ನ ರಿಡಕ್ಷನ್ ಆಗಿದೆ. ಅದೇ ತರ ಕಾರ್ಬನ್ ಇಲ್ಲಿ ಬ್ಯಾಲೆನ್ಸ್ ಆಗಿ ಇಲ್ಲಿ 2 ಇದೆ, ಇಲ್ಲಿ 1 ಇದೆ. ಹಾಗಾಗಿ ನಾವು 2 ಬರ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಲೇಟರ್ ಸೊ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ +3 ಇದೆ, +4 ಇದೆ. ಚಾರ್ಜ್ ಏನಾಗಿದೆ? ಏನಾಯಿತು? ಇನ್ಕ್ರೀಸ್ ಆಯಿತು ಅಂದರೆ ಆಕ್ಸಿಡೇಷನ್. ಎಷ್ಟು ಯೂನಿಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ? ಯೂನಿಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ನಮ್ಮ 1 ಯೂನಿಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. 1 ಯೂನಿಟ್ ಇನ್ಕ್ರೀಸ್. 1 ಯೂನಿಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. 1 ಯೂನಿಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಬಟ್ ಕಾರ್ಬನ್ 2 ಇದೆ, ಕಾರ್ಬನ್ 1 ಇದೆ. ಸೊ ದಟ್ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ವಿ? ಇಲ್ಲೇ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಕೋಬೇಕು. ಮಾಡ್ಕೊಂಡಾದ್ಮೇಲೆ ಒಂದು ಕಾರ್ಬನ್ಗೆ 1 ಆದರೆ 2 ಕಾರ್ಬನ್ಗೆ ಇಂಟು 2. ಸೊ ನಾವು ಐ ಚೇಂಜ್ ಇಟ್ ಟು 2. ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್. ಇಲ್ಲಿ 2 ಹೇಗೆ ಬಂತು ಅಂದರೆ 2 ಕಾರ್ಬನ್ ಆಟಮ್ಗಳಿಗೆ 1 ಯಾವಾಗ ಇತ್ತು ಅಂದರೆ 1 ಕಾರ್ಬನ್ಗೆ ಮಾತ್ರ. ಇಲ್ಲಿ 5 ಯೂನಿಟ್ ಐತಿ, ಇಲ್ಲಿ 2 ಯೂನಿಟ್. ಏನಾದರೂ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬೋದಾ? ಆಗಲ್ಲ. ಇಟ್ ಕೆನಾಟ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್. ದೆನ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ದಿಸ್ 5 with this reaction, this 2 with this reaction. Then when you multiply, you will get 2Mn. This becomes 10. Then this is 2 over. Then this 5 into this. Then finally this becomes 10. 5 2s are 10. Then this also becomes now 2 into 5. This is also changed to 10. This is also changed to 10. Now it comes, this is MnO4 C2O4 5. First see the option whether it is there or not. Yes, it is there. 2, 5. 2, 5. This is 16 straightforward again, right? So option A is the correct option. So this you will get 16 if you balance it by taking 8 oxygen. So you will completely balance 5, 16. So option A, 2, 5, 16 is completely balanced. So we are moving on to the next question. Next question. Identify the correct statement with respect to the following reactions. Identify the correct statement with respect to the following reaction. Let's write down the reaction. Let's write down the reaction. Now, the reaction is something like this. What is the reaction given? Now, the reaction given 2K2 MnO4 Cl2 chlorine converted to KCl plus 2KMnO4. So, what is the question? Which one will get oxidize? I see here K2MnO4. This is potassium manganate. This is called as potassium manganate. This is called as potassium permanganate. So, potassium manganate. Calibrate the charge of this, charge of this. Let's find the charge of this is hydrochloric because it is a free state. Now, K2MnO4. So 2 plus x minus 8 is equal to 0. X is equal to plus 6. So x is equal to plus 6. Then what is the charge of KMnO4? Plus 1 plus x minus 8 is equal to 0. X is equal to plus 7. So this is plus 7. Now what exactly is asking? This is 0, this is minus 1. From here to here, get oxidize or oxidation reaction. 0 to minus reduction. 0 to minus is reduction. So I think the correct option, what exactly the question? The question is, it is like identify the correct statement with respect to the following reaction. So, oxidation potassium permanganate takes place. Potassium manganate. This is potassium manganate. This is called as potassium manganate. This is called as potassium permanganate. This is called as potassium permanganate. Potassium permanganate. So potassium manganate get oxidizes plus 6 to plus 7. So correct option is option A. Correct option. Question number 7. Given this question was appeared in the AIMS as well as once it was appeared in the JIPMER also. Oxidation state of iron in hemoglobin. So hemoglobin is a complex which is responsible for the blood to give the color, red color. In fact, it is a blue color complex which binds to a large number of porphyrin rings. Especially it is present in the blood. So the charge of hemoglobin contains iron, that is ferrous. It has a ferrous. So ferrous is lower valency plus 2, ferric is higher valency plus 3. So the metal ion present in the hemoglobin is ferrous, that is Fe2 plus. He is asking the charge of Fe. So Fe2 plus. So option B is the correct option. Option B is the correct option. So question number 8. Question number 8. So in the question number 8 it is given in the reaction, one reaction is given, big reaction, bromine carbonate to form bromadiene, bromate, bicarbonates are formed in this reaction. Choose the correct statement. Choose the correct statement. Choose the correct statement. Which statement is correct? We need to find out in this. So let's write down this on the board. So this is the question number 8. Charge of bromine is 0 because it is free. Carbonate, charge of CO3 2 minus charge of carbon is, I don't know what it will be, x minus 6 is equal to minus 2, x is equal to plus 4. Charge of carbon is plus 4. Water anyway we don't want. And here it is bromine charge itself is given minus 1. Charge, here it is Br03 minus bromine x minus 6 is equal to minus 1. X is equal to plus 5. Charge of bromine is plus 5. Okay, charge of bromine is plus 5. Then charge of carbon, I think same you will get. I think you will get same charge of HCO3 minus, it is plus 1 plus x, charge of carbon is x, then minus 6 is equal to minus 1, x is equal to minus 5 goes that side, then plus 4. So plus 4. See, carbon charge is plus 4, carbon charge is also plus 4 here. So carbon neither get oxidizes nor get reduces. Then which one get oxidized and which one will get reduced? Let's see now. Now, if you can observe in the types of reaction, I told you disproportionation reaction. Okay, disproportionation reaction. What disproportionation reaction says? Same element get oxidizes, same element get reduces. From here to here, charge is 0 to minus 1, charge decrease, charge down ion. So it is reduce or reduction. Minus 0 to plus 5, charge increase. This is oxidation. And what you confirm? What you confirm? You confirm bromine itself get oxidizes, same bromine get reduces. So what is the exact option for this? So option D is the correct option, where bromine get oxidizes, bromine get reduces. So option D is the correct option for the question number 8. Question number 9. Just see the screen. What is the oxidation number of carbon in C60 fullerene? Regarding information about the fullerene will be given in the P block element. It is a type of carbon compound containing 60 carbon atoms. So 60 carbon atoms, remember and listen my word, it is 50 carbon atom. So in the atomic state, carbon charge is always 0. So the oxidation state or oxidation number of carbon in C60 fullerene is 0. It is a straightforward question. Option C is the correct option for question number 9, 0. Question number 10. Oxidation number of chromium in Cr2O7 2 minus is. Now what exactly this Cr2O7 2 minus? Question number 10. Cr2O7 2 minus. What to find? Charge of chromium. So charge of chromium. Say we don't know, let it be x. So how many chromiums are there? 2. So charge X number 2. Then write plus. How many? What is the charge of oxygen? -2. Not this charge. Separately. Number 7. What is the total charge of chromium? -2. Chromium -2. So 2x minus 14 is equal to -2. 2x is equal to plus 12. X is equal to plus 6. So this is called as dichromate ion. This is called as dichromate ion. This is called as dichromate ion. The charge of chromium in dichromate is X, that is plus 6. So charge is plus 6. So option C is the correct option. Option C will be the correct option for this question number 10. Option C is the correct option.